Okay. In our previous session, we discussed about what is the OLAP, what is the OLTP, right? And what are the
Yes.
different components available in the both.
Mm-hmm.
Okay. Today we are going to see the what are the different schemas available in a data warehouse. Okay. So first of all, what is a schema? A schema is a collection of database objects, including tables,
Sorry, your
views.
voice is a little bit low. Can you please little
Sorry,
loud? Your voice, it is a little bit low.
low.
Mm-hmm.
From my side, it's a full volume only. Can you check now? Is it okay?
Okay, a little bit better. I think so.
Wait, let me connect another headset.
Okay.
Okay, what is the meaning of a schema? A schema is a collection of objects, database object including tables, views, indexes, synonyms. You can arrange the schema objects in a schema model designed for a data warehouse in a variety of ways. Okay, how we are going
Okay.
to arrange these objects in a proper manner? That thing we can call like a schema. Okay, we have a different schemas out there. Star schema, snowflake schema, galaxy schema, like a different schemas out there. Okay. Before going to see the schema, we'll see the what are the different type of tables are there in a schema. Okay. Here we have two different type of tables are there. One is a fact table, another one is a dimension table. So what are the tables available in a schema? Span like a two. One is a fact one, another one is a dimension one. Fact table
Yeah.
holds the mains data. It includes a large amount of aggregated data such as prices, units sold, and some revenue information. Only it can able to tell you measures. Okay.
Mm-hmm.
And a dimension table, which usually smaller than a fact table, includes the attribute that it describes about a fact table. So here in a dimension table, it will give the some complete description about what the fact is specifying. Okay.
Mm-hmm.
Often this is a separate table for each dimension. A dimension table can be joined to the fact table as needed. So here, whenever required, we can able to combine your fact table with the dimension table. That means when you want to see the complete transaction details, then in that time we will combine your fact table with a dimension table. Okay, dimensions have a simple primary key while fact table have a set of foreign keys which is represented like a compound primary key. Okay,
Mm-hmm.
so here your fact table, I can say logically it's a child table and your dimension table is a parent table. Fact table which is inheriting the properties from a parent table. Okay. Okay. See here, this is the first schema. Star schema is we have a centralized fact table surrounded by a dimension table. That thing we can call it like a star schema. Okay. The star schema consists of one or more fact table referencing any number of a dimension table. Okay. In a schema, I can able to have any number of fact table. Okay. That fact table is surrounded by a dimension table. Okay. Here
Dimension.
in this picture, they are calling sales as a your fact and surrounded by a dimension table: product, customer, channel, and time. So,
Mm-hmm.
what is the definition of your dimension? It is provided the complete description about the detail.
Attributes.
Yes, yeah. So here product. So once I go into the product table, I can able to see the product ID, product name, product description, product category, product batch, when it is manufactured, who manufactured it, who is providing this product. Each and every information I can able to see in a product table. All right.
Yes.
Yeah. In the same manner, customer, I can able to see the customer ID, customer name, customer mobile number, address, location, each and every details about your customer. And the channel means, okay, if you are doing a business through the offline or online or by using some third party vendor, so those are the details you can able to see. And time, different type of timing details. Okay, that means it is a weekly one or monthly one or a daily one, like the different variations you can able to see in a time dimension. Okay.
Mm-hmm.
Okay. In a sales table, what I can able to have this. Okay. Here the sales table surrounded by our dimension table. And just I will take one example of your sales record. It contains a sales ID, product ID, customer ID, channel ID, time ID. All 4 IDs we can able to see in a fact table along with the sales ID. Okay.
Yes.
To represent a one sales, we can able to have a one NQ ID, right? Okay. So along with the sales ID, it contains all the dimension IDs, and finally it contains the amount of sold and quantity sold. Okay. So that is a single transaction. So if you want to know about what is the product ID, sorry, what is the product details, that particular transaction is representing only product ID only, right? Okay.
Yeah, yeah.
Here I can able to contain a sales ID, product ID, customer ID, channel ID, time ID along with the measures, amount of sold and quantity of sold. So it is representing one product transaction and one customer, one channel and particular time transaction, right? Okay. If you want to know about you're selling this particular product, what is the product details? So simply I can go with the product table. From there I will inherit all the details. Otherwise, what are the detailed description about a product ID? I can go with the product table, right? In the same manner, if you want to know about the in the particular transaction who is the customer, from which location he belongs to, all that information I can able to go with the customer table. Okay. So simply I can say that these dimension tables are a referencing information, right? Okay.
Yes.
Those details inherited by your fact table when required. So if you want to show the complete transaction, all the details should need to link with your fact table. Okay. One more example I can able to say here. Here I'm telling the one just let me write here only. So here I like this I'm telling that sales ID, product ID, customer ID, channel ID, and time ID, and amount sold, quantity sold. Like this, just assume that okay, some another attributes are there. Okay, this is your one transactional record, right?
Yeah.
Okay. So see here, these IDs are product ID, child ID, customer ID, and time ID. All the things are referencing your dimension tables, right?
Yeah.
Okay. Here I am telling that your fact table is a child table and surrounded by a dimension table. Those are the parent table. So I am telling that it contains some parent and child relation table. Correct?
Which is the parent you're saying?
Dimensions are a parent, fact table is a child.
Yeah.
Dimension fact table, fact is a child table. Okay, here I am telling that. Okay, here if you want to satisfy the primary key and foreign key relationship, so what is the condition you need to satisfy? First of all, a key should be there in a parent table, then only it should be create one
Yes.
record in a child table, right?
Yes.
Okay, that means you need to have a compulsory one a product ID here in a product table that should be there in a child table, correct? Okay, but here we are just as telling that it is a logically looking like parent and child relationship, okay? But when you are going to create a schema, here we are not maintaining the parent and child. That means we are not maintaining the primary key and foreign key relationship.
We don't maintain the constraint?
Yeah, we will not maintain a constraint. Okay, that means if I'm going to have a what is that a product ID, it should be there in here. That thing is not maintaining here. Okay. So how we are going to maintain here? See here, dimension table have a simple primary key while fact table have a set of foreign keys which make up of a
Yeah.
compound primary key. Instead of
Yes.
representing those are like a references, we are representing it like a compound primary key. Okay. So if it is a compound primary key, it is not simply referencing any another table, right? It is just maintaining some unique record only, correct?
Yeah, that's true.
Okay. So here we can able to see the some error handling mechanism for this. Okay, to verify that is to cross verify the your parent and child relationship. What is the thing I am telling that primary key and foreign key relationship. If you have a product table, then only sorry product ID compulsory it should be there in a transaction ID also. Okay, those type of things we can able to see in a error handling mechanism. That thing we will see later. Okay.
Okay.
That day I told you, right, error handling mechanism.
Yeah. So we were inserting a error table.
Mm-hmm.
We were maintaining error table.
Yeah, the same thing only. Okay. Now you have some idea of how you are doing the error. That means without having the entry in the product table, how you can make a transaction, right?
Without making the entry in a
Product table.
dimension table.
Please, in a product table, I don't have an entry. That means in a parent table, I don't have an entry. It is not possible
Mm-hmm.
to do an entry in your parent key table, right?
Yes,
The
I
same,
can't.
yeah, the same thing. By using the same technique only, we are doing the error handling mechanism, correct?
Yes.
That means whatever the IDs I am representing in a transaction, compulsory all the entries should be there in your parent table.
Dimension table.
Yes, those are the
Oh.
dimension tables or a parent table. Okay, that is what we are checking by using our error handling mechanism, and we are identifying your errors.
Mm-hmm.
The same thing only. Clear? Okay. Uh,
Okay.
and here, coming to the star schema, we have a fact table surrounded by a dimension table. All your fact and dimension tables are in a fully denormalized. Okay.
Yeah.
What is a
Mm-hmm.
denormalized thing? Okay. Here denormalization is okay. Normalization means we are maintaining the uniqueness of a data and at the same time I can able to maintain a only small tables, correct? Okay. Here when you go with the denormalized architecture, you will maintain only uniqueness of a data, but different versions you can able to maintain, correct?
Mm-hmm.
So that means some I can able to maintain some duplication also, right? But that is not an actual duplicated, but you can able to maintain some versions of a data also. Clear? Like a SCD1, SCD2. In SCD2, we are maintaining versions of your data, right? Hello, Shiva?
Ravi, I'll just take a minute break. 1 second.
Okay, okay,
Can you please hold on a second?
okay, okay.
So, Ravi, you have family or you're single?
I'm married one.
Oh, okay. Having kids yet or not yet?
Not it, not it.
Oh, that's okay.
It's a one affair only.
Yeah, that's why, like, he was crying. I need to take care of him. That's okay. Yeah, yeah, we can carry on.
Okay, okay. So now you have some idea about the error handling also, right? What is the thing we are doing there, correct?
Yes.
Okay. And here I'm telling that these fact and dimension tables are a completely denormalized one.
Yeah.
Okay. So what is a denormalized one means? Again, a table is a very complex architecture. It contains a complex architecture. That means a table may contain a more than 200 to 300 columns. Okay.
Yes.
That means a complete information I can able to represent in a single table. Instead of splitting like a small chunks, I can able to maintain like a single table to avoid the joins, right?
Mm-hmm.
Okay, that is a one thing, and I can able to maintain some duplication information also. Actually, it is not a duplicated information; it is a versioned information. All right.
Oh, okay.
That means in SED type 2, we are having the slowly changing dimension concept. All right.
Yeah.
There we are maintaining versioned information, but that is not a duplication, right? Different versions of a data.
Yes.
Okay.
So different
So
period of time, different data. Yeah.
yes, but in coming to fully normalized one, there I can able to maintain only uniqueness information. Right. Okay.
Yeah.
Here I can able to maintain some duplicated information also.
Yes.
Okay. So that is your denormalized architecture. So your star schema is a completely a denormalized architecture. And how this star schema is behave. So when I want to perform a one particular transaction, this fact table can be do the left join with your dimension table and to cross verify each and every detail is satisfying or not. Correct?
Yes.
That is what we need to do take care, right? At the time of doing the final star query, correct?
Yeah. Ravi, like I have one question.
Mm-hmm.
Uh, the data warehouse, if you see schemas, Mostly we have star schema, like some organizations, they have a snowflake
Yes,
schema,
correct,
right?
correct, correct.
So once the organization decides, then as a data warehouse developer, we are the one who creates this dimension table and fact
No,
tables, right?
no, we are not supposed to do these things.
Uh-huh.
We are not. We are just involved in the some guidance only.
Okay, okay,
Okay, we have a special person, data architect will be there.
okay,
So that person will take care about all these things, data architect. Okay,
okay.
so he completely involve interact with the business. Okay, from there he
Mm-hmm.
will get the complete information and he will do the complete modeling.
Okay, they will be doing the data modeling and we will be importing the table structure and load it.
Yeah, that's a simple thing. But we need to have some idea what is the dependency between one table to another table at the time of
Yes.
doing the final transactions.
Mm-hmm. Okay.
See here, I want to load the sales information. Okay, finally sales transaction I want to load. So from all the staging tables, I will get the data and I need to do some left join, correct?
Yeah.
To get the final transaction, sales transaction. Okay.
Mm-hmm.
So to do that, I need to know the dependency. Okay. So here the sales table is depend upon all these tables. So I need to do a left join to cross verify all the details are correct or not. Correct.
Yeah.
So without knowing the schema architecture, we can't do, right?
Okay.
So we can have some basic idea. So they will provide the complete details. So what is the design they are going to do that? Okay, from a conceptual level, logical level, physical level, all the diagrams they will provide to us.
Okay. That's good.
Okay, yeah. So we no need to worry about that. Okay, database architecture will be there. Okay, we can that person will take care about all these things.
Mm-hmm. Okay.
Okay. So what is the thing? Advantage? Provide direct and intuitive mapping between the business entity being analyzed by end user and the schema. So I can able to easily understand the schema thing and provide the highly optimized performance for a typical star queries. So compared to the other
Yeah.
schemas, star schemas always have a high performance. What is the reason?
Yeah.
It don't have unnecessary joins, only this direct thing. Okay. So how I am seeing in the same manner, I can able to perform a join, correct? Simply I can able to tell
Yeah.
to get the final transaction, this sales is doing the left join with all the tables, right?
Yeah.
Simply I can able to tell that. Okay. And are widely supported by a large number of business intelligence tools and which may be anticipate or even require the data warehouse schema container dimension table. So max schemas, that is the final end, what we are going to build. Max, so many BI tools that are reporting tools, max they will support us a star schema. Means there also if you're they're going to do a snowflake schema, if they want to display their dashboards again they want to do a joins only, correct?
Yeah. They have to modify, customly modify it.
Yes, yes. They need to write some queries. Okay, so it is giving us some issue. Okay, so all the BA tools very largely it is supported. Okay, so max
We can
organizations, yeah, tell me.
we can add one more advantage. It is easily extensible.
Yes, yes, yes. So
Yeah.
simply placing a one key here,
Look.
yeah,
Yeah.
one more key here, and simply doing this thing. Okay.
Yeah.
And the snowflake schema. Okay, so snowflake schema also look like the same as a star schema only. The only way, okay, snowflake schema. It's a surrounded by a sorry fact table surrounded by a dimension table. Here your dimensions table are get normalized. Okay, in a star schema all are denormalized. Here your dimension table they may be changed like a specified like a normalized tables. Okay. A snowflake schema is represented by centralized fact table which are connected to multiple dimension table. In a snowflake schema, dimensions are normalized into multiple related tables. Whereas
Okay.
in a dimension modeling, dimensions are denormalized which are represented like a single table only. That means table we can represent like a one complex table only. But in a snowflake schema, tables are represented like a small tables. That means dimension tables to avoid the complexity.
Okay.
So if you have a very complex table and your application is also very complex, okay, just like
Yeah.
your banking and financial services system, okay, so
Mm-hmm.
what is the thing? They need to maintain years of information compared to the regular service-based projects. So BFS is a very complex one, right?
Yes.
They need to maintain the years of information, years of transactions they need to maintain.
Mm-hmm.
Okay, just for analysis purpose they need to maintain. Okay, and at the same time, okay, if I want to show anything for a customer, I need to show all these things, correct?
Yeah.
Okay, so there if you maintain all the information complex table, maintainability is highly difficult, correct?
Mm-hmm.
So because the reason they try to split your dimension tables like a small dimension table. So if you have a normalized tables, I can able to maintain the data easily. Okay,
Mm-hmm.
maintainability easily, but at the time of performing final transaction, okay,
Yeah.
performance issue.
It will take a lot of time.
Yes. So simply, okay, here to get the final transaction, sales table is doing the linking with the timetable, product table, customer and channel, right? And if I
Mm-hmm.
want to get the product table, this product table is doing left join with the supplier table also, correct?
Yeah.
So it will get the complete of product information. Okay, so simply can able to say that. Okay, just I will write down the select star from sales fact. Okay, left join, left join on product table. All right.
Yes.
Simply I can able to specify like a product table which is a star schema, correct?
Yeah.
Okay, but here I need to represent like this. Okay, select again, select star from your product table.
Product table with the suppliers.
Yeah, product table which is going to do either left join or a join. Okay, product table join on a supplier table.
Mm-hmm.
Alright. So again one more joining is there, correct? For each and
Yeah.
every okay, before it is going to perform, it need to join these details, correct?
Mm-hmm.
Then only the final result will be do join with this.
Yeah.
Okay.
You can
So
do join with customers, with the
yeah.
countries.
Yes, the same thing. So I'm going to add a some another burden, right? If you have a
Yeah.
more number of joins, automatically perform will degrade. The number of joins increasing, performance step by step it will degrade, right? And that too we have a normal, those are not like a sequential joins, like it is inner joins, right?
Yeah.
Means if I have a one by one join, then it is not a issue. All will perform like a sequential manner. But here
So
this
let's.
join need to execute, then only this join need to execute, correct? Dependency is
Mm-hmm.
there. So it is a holding the thing, okay? So because of reason, okay, Snowflake schemas always have a less performance compared to the star schema,
Yeah.
okay? But people who are going with the complex organizations, they will go with the Snowflake schemas only, okay?
Mm-hmm.
If they want to maintain a data redundancy, people will go with these things, okay? Means based on any other project requirement, people will go with this type of schemas. Clear?
Mm-hmm.
So advantage. So some overlap dimensional database modeling tools use a dimensional data merge as a data sources or optimizer for Snowflake schema. Some overlap thing they will only use a data marts. Okay.
No, I didn't get it.
Yeah. Instead of complete data warehouse, they will use the data marts only. Okay.
Yeah.
So for that type of situation, I can able to represent. Okay, if you are
Oh,
maintaining a complete warehouse, it's a highly difficult. If I go with only marts, that is not an issue, right?
yes.
Okay, and it's not.
Performance will,
Yeah,
it will be like much easy than
yeah, yeah.
applying to price level.
Correct, correct. And Snowflake schema can sometimes reflect the way how user thinks. See here, the same thing what is telling that. Okay, simply I think that product information available in a product table, supplier information available in a supplier table. Okay, and
Mm-hmm.
there will be a link between product table to supplier table. to differentiate. Means of from which supplier I'm getting this product, like that link will be there between product table and supplier table, correct? Coming to the star schema, both supplier and product information will be specified in a single table, correct?
Yeah.
Okay. See here, for suppose from a supplier table I am retrieving the 10 columns, okay? For each and every record I can able to specify the 10 columns, correct?
Yeah.
Okay, that means the complexity will be very more, right? Otherwise,
Yes.
in a simple, okay, if I try to get the join by doing the joining this supply table and product table, in a supply table I can able to maintain only suppose only 10 suppliers are there, okay?
Okay.
Just assume that only 10 suppliers are there and I have 1 lakh of products are there. Okay, simply product details, and at the end I can simply have supplier ID.
Yeah.
Simply by that I can enable to join with the supplier table and I will get that thing.
Yes.
Okay. If you do it in a star schema for all the 1 lakh records, I can able to maintain all these 10 columns also, right?
Yes.
That will be a more burden, correct?
That's true.
Yeah, because the reason people will go with the joins only, right? In a some situation, okay, this type of
Yeah.
a situation, okay.
Okay.
That means if your project is very complex, people will go with that approach. Otherwise, they will go with the star schema only. That means they are compromised with the size, they will go with the star schema only. Okay. But people will not able to maintain all the data. They will split the into small chunks. Okay. Simply with this example only, we got some idea, right? In a product, I have a
Yeah.
1 lakh of a different type of products, but only 10 suppliers are there.
Yes.
Okay, and this is 10 supplier. From a supplier table I am inheriting 10 columns. Okay, so for all the 1 lakh of records I need to maintain again that 10 columns, correct? That will be very bulky, correct? Otherwise, simply if I try to do the join when required, I will get those details simply by doing the left joins, and from there I can able to only maintain 10 records.
Yeah.
That means here I am maintaining in the product table 1 lakh of records of suppliers, right?
Yeah.
So because the reason, okay, to avoid the complexity, some organization people will go with the snowflake schema. Clear? The same thing telling that. Okay. If your dimension is a very sparse, okay, that means most of the possible values for the dimension have no data, or dimension is a very long list of attributes which may be used for a query. Okay, that means if I have near 200 to 300 columns are there. Okay.
Yeah.
The dimension table may occupy a significant portion of a database. Okay, in that situation, Snowflake may be appropriate. It is better to go with the Snowflake schema in that situation. Clear?
Okay.
That is the advantage of your Snowflake schema. Okay, let me show some real-time schemas. See here. Can you tell me that by seeing this diagram, whether it is a star and a snowflake, which one it is?
I'm not still getting which one. Okay, here. Wow. The schema is like.
It's simply one, a simple schema. It's a very simple project only.
Okay, so promo code, and then exception log assignment.
Simply,
And
a simple logic. By saying this, this promo code is your fact table, right? Which have a compound primary keys. Okay.
yes.
And this exception log also your fact table. Okay. So fact table surrounded by dimension tables, and here this employee is a dimension table. Okay.
And it has
And
the lookup table. So
yes, employee table have that normalized
snowflake.
snowflake. Simply I can able to tell it as snowflake one. Okay. So this employee is inheriting the details from a job family and job function. See, the same example in just now only I given, right? I have a millions of employees in my organization, correct?
Yeah.
Maybe I have a 10 lakh of employees worldwide. Okay.
Mm-hmm.
Maybe I have a job families like near to 1,000 job families only there. Different categories
Yeah.
of jobs. So if I have a 10 lakh of employee and I am representing with a job family with this thing, very complex. It will become a very complex, right?
Yes,
At the
yes.
same time, job family and job function. For different job families, they will do the same type of some functions only, job functions, correct?
Mm-hmm. Yeah.
So compared to this will contain less number of records because the reason it is split like a small tables
Yeah.
to maintain a data redundancy, right? That means I can able to maintain less information only, correct?
Yeah. Mm-hmm.
Okay. So simply by saying this, I can able to tell it like a star schema. Okay. Sorry,
No,
not
no, it's not.
snowflake. Okay.
Yeah.
So see here in this small schema, I can able to see the two fact tables are there, right?
So promo code is one fact table
And
and what is,
exception
yeah,
log,
the
exception
exception
log.
log.
Yeah.
Okay.
Exception log is shared by a campaign, employee, and the exception type. Okay.
Yeah.
Like a two fact tables are there, and these are all the dimension tables. Clear?
Mm-hmm. Yes.
Okay. Let me show the summary of the schema. How you can able to see the insurance schema. This is your insurance schema. Okay. So this pro is the fact table surrounded by these many number of dimension tables.
It's still loading for me. I didn't
Oh,
see it yet.
able to see?
Uh-huh. Not yet. Okay. Now I do.
Yeah.
Now my head is spinning.
Okay.
Uh, I don't know. Where is the fact table?
This one I can able to see. This is the main fact table.
Okay.
Okay. So it's a very complex architecture, alright?
Yeah.
So with this small things and will difficult to identify that. But if you have a complete modeling and we can able to say that which one is the fact table, which one is it. But this is I can say this is the probe is the main fact table, alright?
Mm-hmm. Yeah, like a
So,
lot of
so
connection.
yeah, a lot of connections are there. Okay. Like this we can able to see from an insurance system we can able to see this much of a complex architectures are there. Okay.
Mm-hmm.
So policies table. This is a policies table surrounded by all the dimensions. So policy is the main fact table, right?
Mm-hmm.
Okay. Like this,
So it looks like a snowflake only because there are like,
yes,
wow, this one.
it's a snowflake only. So many flakes are there, right?
Yeah.
So many splits are there. Okay. So policy cluster. Like this, we can able to see the different real-time schemas. Okay. Yeah. So dimension modeling. In the dimension modeling, what the thing we can able to see there. Okay. So what is schema? So arranging all those things is a call like schema modeling, right?
Yeah.
That thing we can call like a dimensional modeling. So first of all, we need to identify what is a fact table and what is a dimension table. After that, we'll model them by using our relationship, right?
Mm-hmm.
Okay. Dimensional modeling is a name of a set of techniques and concepts used in a data warehouse. Dimensional modeling always uses the concepts of facts and dimensions. Okay. So it need to
Yeah.
identify what is the facts and dimensions first. Okay.
Mm-hmm.
And the facts are typically numerical values, can be aggregated, and dimensions are group of hierarchies and descriptors that define a fact, right?
Yes.
Okay, so dimensions are always a descriptors and facts are always a numeric values and aggregated values. Okay, and here we have a different type of fact tables, different type of facts are there: additive, semi-additive, and non-additive. Okay. Okay, additive means additive facts are facts that can be summed up through all the dimensions of fact table. Okay.
Okay.
That means a fact table which contain a link with each and every dimension table. Okay. So simply in our above schema, your sales is a additive fact table that is surrounded by a product, channel, customer, and time dimension. Right?
Mm, I do.
Additive. all the dimension. That means a fact which contains all the dimension. That means which is covering each and every dimension. Okay.
Okay.
So here also this promo code is covering all the tables, right? Okay. This one, and all the maximum dimension it is covering, correct? Okay.
Yeah.
So a fact table which is covering each and every dimension, we can able to call it like a additive fact. Okay.
Okay.
Next one is a semi-additive fact. Okay. What is the meaning of a semi-additive fact here? Semi-additive facts that can be summed up for only some of the dimension of fact table, but not the others. Okay. So here I will create some fact table. No need to maintain all the information. Okay.
Okay.
Okay. That means that particular transaction I no need to involve each and everything. Okay.
Mm-hmm.
So there I require only suppose I want to speak about the product information and based on a particular channel only. Okay. So I am doing the final transaction. There I want to have only the product and channel information only. Only those information I will link. That's enough, right?
Mm-hmm.
Just I want to show one dashboard. There I require only the sales information only. Sorry, product information and the two are channel information. That means product wise sales and channel wise sales. No need to about the customer wise sales, right?
Yeah.
No one will bother about the customer wise. So in that situation, no need to involve all other things, correct?
Mm-hmm.
Okay. See here in the above example, that fact table is representing each and every information, correct? Okay.
Yes.
And in the fact table, no need to involve some fact table. No, they don't want to maintain the customer details. What is the need of a customer details? I want to just share final revenue wise, product wise and a store wise and some time wise. That is information is enough. No need to maintain the customer details here. Correct?
Okay. So that requirement it will come from the business, right?
Yes.
I don't want to maintain like a customer level.
Yes, yes, yes. Okay. That means I
Okay.
just want to do means I want to create a one dashboard. There is no need of a customer wise information. Okay.
Mm. Because like some businesses they analyze like geographically like people from this city
Yes,
spend
yes. In that,
more,
yeah, in that
more.
situation, that is another thing. Okay.
Okay, it's totally depend on the business.
Yes. Okay. If they want to create a one type of a dashboard, that is only represent the product information, channel information. This thing is enough. Okay. And what are the
Mm.
example you are telling? They want to go with this particular geographical level also, right?
Mm-hmm.
In that situation, I want to go with the customer also, right?
Yeah, that's
That
what
is
I'm saying.
that is purely depend upon a customer a business requirement. Okay.
Mm-hmm. Okay.
Another thing. Okay. So non-additive fact. Non-additive facts fact that cannot be summed up from any of the dimension table in the fact table. Okay. See here, this is
Mm-hmm.
the thing. Okay. In this example, which is not going to link with any of the dimension table. What are the information available in the current fact table? They will depend upon only that information only, and they will create a one final fact table. Okay.
Okay.
Means what are the information available in the staging? They will try to get only that information, and finally they will show one fact table which is not linking the any dimension. Just I want to say one example. In a previous session, I told you that year over year values, correct?
What is that year?
Year over year delta.
Year over. Yeah, yeah. Like comparing between like two different years.
Yes, yes. Okay, that means that I told you an example. Okay, my business want to display one dashboard which contains that year over year delta values. Okay,
Yeah, yeah,
that
yeah.
means comparing current quarter with the previous quarter, current financial year with the previous financial year, and region
Yeah, yeah.
wise. Yes, yeah. This type of
Mm-hmm.
things I need to maintain, right?
Mm-hmm.
Okay,
So you directly calculated the value and put it on a fact table
correct.
because they didn't want to do any querying. So
Yes.
you created query and put
Yeah,
it.
so finalized fact table, I will completely aggregated fact table with each and every information. There I
Mm-hmm.
no need to maintain a product wise information, right? Or any
Okay.
another information. I want to see the final revenue. That means a year wise thing, correct?
Mm-hmm. Yeah.
So that is a different requirement altogether, completely.
Yeah.
So no need to maintain any linking with any table. So what is the value I have in my table? Only the value I have what is that? I have some measures only. Okay, that too year-wise measures. You want to see like a final end, final fact table that contains each and every information. Okay. So in that time, you can go with the non-narrative facts. Okay.
Mm-hmm.
Another one, based on these two things, it is categorized like a cumulative fact table and snapshot. Okay. This type of fact table describes what happened over a period of time. For example, this fact table may describe total sales by a product, by a store, by a customer region, each and every information it requires, right?
Mm-hmm.
So these tables are, I can able to say, additive fact tables are cumulative fact tables. Okay.
Okay.
So these facts are almostly additive fact tables. And a snapshot. This is the type of a fact table that describes state of a things and a particular instance of a time are usually include more semi-additive or non-additive facts. Okay. Here I no need to maintain any information, right? I no need to
Yeah.
care about anything. Okay. So all your semi-additive and non-additive will come under the snapshot. Okay. That is just now like I told you one example, alright? Okay. No, that means I don't want to maintain each and every details. So in that case, I will go with the snapshot. Okay. Okay. By the end of the session, I will show that real-time example for that non-additive fact also, how it look
Okay.
like. Okay. That system is going to restart. Okay. By that, we'll discuss this thing. After that, we'll show you that. Okay.
Yeah.
And
Mostly like our fact tables are cumulative, right? Like we would be.
yeah, there is a purely depend upon requirement only.
Oh, okay.
Okay,
Recommended.
means
Okay.
how business want to see in the same manner they will add the columns and they will do agreed operations by using our ETL tool. Purely depend upon the business requirement.
Okay.
So dimension is a data element that categorize each item in a data set in a non-overlapping region. A data warehouse dimension provides a slice to dice.
Mm-hmm.
So dimensions provide a structured label information to otherwise unordered numeric measures. Okay, see here, what is a slice to dice? I will split in like a small pieces, data into a
Mm-hmm.
small pieces. Okay, and each piece don't have a relationship to any another piece. Correct? Okay, simply all the
Yeah.
dimensions are not a dependent on any another dimension. Each and every dimension will be an individual. Correct? Just take our
Yeah.
schema modeling only. Product dimension is not depend upon a customer. All right? Customer is not
Mm-hmm.
depend upon a channel, correct?
Yeah.
Okay, they don't have any dependency. Okay,
Mm-hmm.
okay. Here, maybe I may be a person of India. I can come to US. Maybe I can do some sale, sort of some transaction, right?
Mm-hmm.
It is not depend upon a region of a thing where I am located, correct? Maybe like some tourist I came to your city. From there I will do some transaction, right?
Yeah. Yeah.
But I'm
We
not
can
supposed to,
do.
yeah, I'm not supposed to depend upon your region and okay, because of this person only and this person so frequently visiting your country and I can say that my transactions will be increased by this person's not like that, correct?
Mm-hmm. Yeah.
Okay. So you are not supposed to say there is no linking between one dimension to another dimension. In your final transaction load also that I had shown you, right? I think I didn't show that thing ETL load in a real-time ETL load. That day I shown you the this thing, right? What is the idle scheduling tool?
Yeah. Yeah. That is
Yeah.
schedule.
And there you can able to see that all dimensions are run up parallelly, and your transactions maybe they will run a one-on-one. Okay.
Mm-hmm.
So there is no relationship between one dimension to another dimension. So yeah, we can able to do our dimension loads parallelly. Correct.
Mm-hmm. Yeah.
After that, once your dimension loads are done, you will do a transaction load. Okay. And here we have a different type of a dimensions are there. Conformer dimension. Okay. So
Mm-hmm.
what is a conformer dimension? A dimension which is shared by a one or more fact table. We can call it like a conformer dimension. Okay. Simply, I can say this campaign ID is shared by a one or more fact table. Okay. Campaign ID is shared by this promo code and exception log also, and employee table is shared by this table and this table. So I can able to say this campaign ID and employee table, both the table are conformer dimensions, right? The definition in a data warehouse, a conformer dimension is a dimension that has the same meaning to every fact which it is relates. Simply, I can able to say one more definition. A fact table which is shared by a one or more, sorry, a dimension table which is shared by a one or more fact table.
Okay.
You can call it like a conformed one. Okay.
Mm-hmm.
That means in each and every fact table, it will project the same meaning only, right?
Okay.
See here, here it is employee table. Here also it's an employee table. Coming to this fact table, what is the details it have? The same details it will show share with the two fact table. Okay. Here in
Okay.
this level it is not going to hide something. In this level it is not going to hide something, right?
Mm-hmm.
So the complete
Same information.
information is the same. It will share with both the fact table. Okay.
Yes.
Okay. That is a conformer dimension.
Okay.
Junk dimension. A junk dimension is a dimension table that consists of attributes that do not belong in a fact table or in any of the existing dimension table. The junk dimension should contain a single row representing blanks as a surrogate key that will be used in the fact table for every row written with a blank comment field. Okay,
Oh.
that is the one thing. Okay, the designer is faced with the challenges where to put attribute that do not belong in another table dimension. So solution is to create new dimension table for each remaining attributes, but due to their nature, it could be necessary to create a vast number of a new dimension resulting in a fact table with a very large number of foreign keys. Yeah, see here,
Oh.
we have some dimension tables. Those are not belongs to any fact table or any another dimension table. Okay,
Okay.
I can able to get some attributes. Those are not belongs to any another thing. Okay. So just to take that here they are giving that in a junk dimension they should contain a single row representing the blanks as a surrogate keys. Okay, that will be used in a fact table wherever I want to show some blank information. Okay, blanks like a comments. In that situation, simply I will link with your junk dimension. Okay, that is a one example. Okay, I am giving another thing. See, I want to represent the surrogate keys. Okay,
Okay.
okay, here where I require the surrogate keys in SED type 2, right?
Yeah.
In SED type 2, I require surrogate keys. Okay, is this surrogate keys belongs to any another table?
No.
No. Okay, if a table contain only surrogate keys, okay, that means only it will maintain unique keys only. Okay,
Yes.
whenever I require, simply I will link with those things from a fact table. I will get that surrogate key information. Okay,
Yeah.
but if
But
you
we will
call,
use a sequence generator, right, for
yes, yes,
doing that.
means I'm just taking some example. Okay.
Okay.
In our real time, okay, I'm just specifying that if you have all those type of surrogate key information in a one
Mm-hmm.
separated dimension table, instead of you are generating from a sequence generator, suppose you have all that information in one table.
Okay. Then I will be using that.
Yeah, you can call, yeah, I can able to use that one only, right?
Yeah. Yeah. Yeah.
If you don't have, if you completely don't have a concept of a sequence generator, I need to maintain a one table which contain all the unique keys, correct?
Mm-hmm. That's true.
That only I need to use that. And can I say, is there any meaning of that sequence number? No, right? It don't have any meaning.
Yeah.
Okay. So those type of dimensions I can able to call like a junk dimensions. Okay.
Okay.
Yeah. See here. Here they given one more example. A dimension which cannot be discovered like a fact. Okay. So address. So I am maintaining some addresses and some phone numbers, some product descriptions. Otherwise, some city informations I am maintaining. Okay.
Mm-hmm.
Those are not like any descriptors. Simply, I can able to get that city information from there, right? Whenever required.
Yeah.
Okay. Some product descriptions. So it is not representing anything. Okay. So
Yeah.
those type of things I can call like a junk dimensions. Okay.
So it will be a separate table with the
Yeah.
product ID
Yes.
description.
Which is not giving any another information. Okay.
Mm,
I can
okay.
call those type of things like a junk dimensions. So another one is what is a degenerative dimension. So degenerative dimension, a dimension key such as a transaction number, invoice number, ticket number, or a bill of landing number that has a no attributes and hence does not join to an actual dimension table. Degenerative dimensions are very common when the grain of fact table represent a single level of item. Okay, what is the thing they are telling that? Okay, see here in the above example I told that I have a this is surrogate keys. That is a one type of a thing. Okay. Another
Mm-hmm.
thing, if a dimension table which is maintaining one invoice number and invoice number description only. Okay.
Okay.
Okay. Suppose I'm telling one particular transaction. That particular transaction is representing. Okay. If you take the one PNR number. Okay.
Mm-hmm.
PNR number of one person journey details. With the PNR number, I can able to represent only 1% transaction details only. Correct.
Yes.
Okay. So I can able to maintain only uniqueness of a transaction. You are not supposed to make multiple transactions with that person, right? With that PNR number.
Mm-hmm.
Okay. And that too, your PNR number have any description about the PNR number which is going to explain you anything? No. Your PNR number is just a random number, right?
Yeah.
Okay. If a table which is maintaining this type of information, I can call those type of like a degenerative dimensions. Okay. A dimension keys which is making your fact table to maintain the only uniqueness of information. Okay.
Okay.
Degenerative dimensions are very common when the grain of a fact table represent a single transaction item or a line item because the degenerative dimension represent the unique identifier of a parent. Okay.
Mm-hmm.
I can
Okay.
able to have only uniqueness. Okay.
Mm-hmm.
Degenerative dimensions often play internal role in a fact table like a primary keys. Okay.
Primary key.
So those things I can call like a primary keys also. Okay.
Okay.
So that has only a keys only and some small attribute. Okay, a single attribute only, which is representing some description, but it don't have any attributes. So those type of tables I can able to call like a degenerative dimension table. What is another definition here? A degenerative dimension is a dimension which is derived from a fact table or does not have any another dimension table. Okay. So I have a key, fact key is there, like a transaction key is there, sales, product, customer, channel and thing. Along with that, you have a PNR number key also there, like a transaction ID also there. Okay.
Okay.
In another table, you are separately maintaining those details and you are having that information. Those type of table I can call like a degenerative dimensions. Okay. Clear?
Okay.
So I guess we can able to have a different type of dimension tables and a different type of fact tables are there. Okay. And coming to the dimension modeling, what is the purpose of this thing? So choose the business purpose, declare the grain, identify the dimension, identify the fact table. So first of all, what is a business? Grains means for a low level of information I need to identify, right? Each and every information I need to identify, correct?
Mm-hmm.
After that, from there I need to identify the what is the dimension, what is a fact table. After that, I need to arrange them individually. Clear? So how this
Yeah.
a data architect will do? Let me show one example. Okay, before they are going to start our project, see here. You see here. They are identifying the each and every table, their columns, their data types, and each and everything they are identifying here, right? Tables and attributes. First of all, they are trying to identify each and every information, correct? Able to see my screen?
Yeah.
Yeah. So in this Excel sheet, they identified, okay, before they are going to start the project, first of all, they identify all the tables required for your project, and they identify the columns and the data types of that, okay? Each and every
Okay.
information they capture. That means all the table information they capture. After that, they're providing the relationship. What is a primary key table? What is a foreign key table? Okay. Once they decide the each and every relationship, finally they will go with the data. That means the designing. Finally, they will go with this design. See, first of all, they will go with the conceptual model. Based on the details only, they will try to arrange like a schema. Okay. So conceptual model, logical model, and finally they will go with the physical model. These all the things will be done by your data architect only. Okay.
Okay.
The same thing, the initial process only. So I can able to choose the business from there declaring the grains. Grains means small information, right? Piece of information, each and everything I need to maintain. After that, from there I will identify what is a dimension table, what is a fact table. So finally, what is the benefits of your dimension modeling? Understandability, quality, performance, and extensibility. So I can simply understand what is the thing going on by using this modeling, right?
Mm-hmm.
Okay. And simply the same thing, you are telling that by seeing your architecture, if you want to do extend it, simply I can able to know that where I can able to add the new elements, right?
Yeah.
So this is the purpose of your dimension modeling and data modeling. Actually, data modeling will come into the first picture after the dimension modeling is coming. Okay. First of all, I need to do a data modeling only, right?
Okay.
After that, I will do a dimension modeling.
Oh, agree.
Yeah, yeah, yes, yes. Now, is it
Yeah,
okay?
it's good.
Yes, yes. I connected
It's
another
good.
system also. So based on the reason it is giving echo.
Yeah.
Yes, understood. Just wait. You able to see my screen?
Not yet. Slowly. Yeah.
Yeah. Okay. I tell you the example of non-native fact table. All right. Okay.
Okay.
This is the actual fact table. Okay. Time period and comparison period and counter discount, gross revenue, year-over-year value is there. Right. Okay.
Okay.
But it's
Yeah.
depend all are these are all are measures only. Correct. Okay, this is
Yes.
the actual table. Okay, time period, contract discount, only gross revenue is there. From there, I'm creating this stage one. Okay, So
Okay.
comparison time period, contract discount I'm cross verifying, gross revenue and year delta value I'm calculating here. Okay. Based on your
Okay.
gross revenue and precision point of delta. This is the information I'm calculating. And from there, I'm identifying for each and every level. Okay.
Mm-hmm.
Actually, what the thing they're doing for a level wise, they need to show the analysis information. Correct?
Mm-hmm.
Okay, we have 6 levels of business are there. Okay, region level, country level, and sub level, like different things are there. Okay, 6 levels of business are there.
Mm-hmm.
Okay, so for each and everything, again I need to split. This is the same thing. Okay, see here, like we have a different regions are there. Level 0, it is representing 3 regions: AMS, APJ, AMS, EMEA, AMS, APJ, okay, and sub-region, okay, business one, and another level, and country level, and another level, like different things are there, okay.
Mm-hmm.
So my dashboard, that means reporting team want to show this level of business, okay. For all that thing, they want to display this information, year calculation. All this are 12, I think near to 12 calculations are there. All these 12 calculations they want to do in a reporting side, okay.
Mm-hmm.
Assume that how much time it will take to respond or by calculating in a reporting side. It will take a very huge performance hit, right?
Yeah.
I need to bring up forward values and to the backward values and will compute each and every one, and then only I will get a year value, right?
Yeah.
Okay.
So
And can you see that is there any another keys are involved here? No.
key the contract at ID.
That means it is representing that particular transaction only.
Okay.
Okay. So rest of all the things are measures only,
No.
correct?
Yeah.
All are
Yes.
measures
Yes.
only. Delta value, precision point, basic point, each and every information, correct?
Mm-hmm.
Only this maintain that a contract ID to represent this contractual discount. Okay.
Okay.
So I can say this is like a non-additive fact table finally, correct? Which is not involving any other information, right?
Yeah.
This type of requirements also you can able to see that. Okay, for this I think nearly they asked me to just do a one POC on this. Okay, currently business feeling some performance issue at the time of showing the dashboards for a responsive time. Okay,
Mm-hmm.
and they asked me to try to build the same type of fact table in a database level. Okay, for this I think
Okay.
I read, to achieve this thing I think I written near to 20 queries. But just like I done it like on a POC, project not came to us. They expected to came, but it is not came to us. So the thing I done it's a waste of business only.
So this is like a schematical change, right now, Ravi? Like you will be asking the DBA to do it, means like permission and everything.
Yes, means for our development level, we have all the things are there, right? All the permissions are there in my organization. Okay.
Okay,
What are
okay,
the thing I require? I can able to do anything in a development level. Okay.
okay.
So see here the in the real time how it will happen. First of all, your business that is a complete architect level they will decide on a modeling. Okay,
Mm-hmm.
for your Informatica thing. Otherwise, any business requirement they want to add some new columns, they will add. Okay,
Okay.
if you want to introduce any another new columns or a new table for your temporary purpose like a staging purpose. Okay, or any purpose you can able to introduce and you need to inform to the business, yeah, this is the tables I introduce, try to create in all the levels like ITC and production. Okay,
Okay.
so what are the modification you need to do that, you need to prepare a one query, you need to give it to your admin, try to execute it these things in all the levels. Okay,
Okay. Okay.
yeah, just a thing. Okay, I will take one example. Okay, I'll take one particular key column like a numerical. Okay,
Okay.
they specified it like a numerical value, but you are not supposed to load a numerical value into that. You want to store some varchar information into that. Okay.
Okay.
Simply you will change the data type and you will inform that I am going to change this data type. Okay.
Yes.
Either you feel that these are the columns are not required at all. Simply you will drop that columns and you will inform your business these are the columns are got dropped. Okay. But it is not a single person decision.
Okay, okay. So it's
Okay.
like a whole business's requirement and the whole team's decision to do it.
Yes. They depend upon a complete team decision. Clear?
Okay.
Like this type of requirements also you can able to see that. Clear? See from this small four columns, okay, from these four columns, I need to convert this like this many number of things. Okay.
Yeah.
So much of linking is there. Finally, I need to show like this. Okay. Final fact table. Here to taken here to 10 days to build all the queries. Finally,
Oh.
I achieved that, and I told that I'm telling that my lead it is showing the wrong result compared to the dashboard to my end. Okay. What is the thing? I taken a wrong table for my data analysis. They have one more table. I taken another table. I keep on telling that he is showing the wrong information. Then he asked me to correct your query like it. But finally, I come to know it is a wrong table.
Oh.
Okay. Like these things also can.
Okay.
Yeah. So coming to the data modeling. Now you able to see my screen?
No, not yet. Still loading. Yeah.
Yeah. So here directly I will go with this tabular example. Okay. See here, we can able to see that at the time of doing the data modeling, we can able to see the three different modelings: conceptual, logical, and physical. Okay. So what is the conceptual model? So once you identify the business, you need to identify what is the entity, what is the relationship. Okay. Means what are the entities are there in your project and what is the relationship between each entities. Okay. So that thing we are called like ER modeling in your business. Okay.
Okay.
I think you heard that terminology, ER modeling.
Yeah.
That means you know that Irwin tool, right?
Irwin, yes.
Yeah, in that
Data model.
yeah, and there first of all they will do the ER modeling initially.
Mm-hmm.
Okay. So after that, once they identify the entities, in the entities they will try to identify what are the attributes, primary keys and foreign keys they require. Just now only I shown you some example of some Excel sheet, right?
Yeah.
Okay, they identified all the attributes, primary keys and foreign keys in that Excel sheet, right?
Yes. Yes.
Okay, so here you need to identify attributes and primary key and foreign keys. Okay, and you need to give the logical relationship between one table to, that means one entity to another entity. Okay. Okay, here this entity and relationship. Okay, the will convert like sorry, your attributes and entity names will convert like a table names and column names. Okay.
Yeah.
Entities and attributes are represented like a one standardized name, that is a table name and column name and data type. Okay. If you see the some example, see here, this is your conceptual model. So here they just taken on a sales project. That means what is the schema we discussed right previously. Okay, the same example they taken. So is a sales schema. Okay, sales surrounded by a dimension table, and simply they are representing the linking only. Okay, after that they define the what is a primary key, what is a foreign key, and attributes they identify. And finally, based on the attribute nature, they give the all the data types and they given a proper naming. Okay, so fact is a fact and dimension is a dimension, like that they specify. Okay. So like this, you can able to see the data modeling also. This is the initial part of our business. Okay.
Yeah.
Okay. Actually, this type of things only there. Okay. Based on the assignment. Okay. Based on the final schema, people are calling like a different type of fact tables and different type of a dimension table. They are simply identifying that. Okay.
Okay.
They will not bother about what is the type of fact table, what is the type of a dimension table. They will try to go with this type of only. Okay. Whether it is identity fact table or semi-identity fact table, they won't bother. Okay. Finally, they will give up one architecture. Based on that, you need to identify whether it is additive, semi-additive, non-additive. We need to identify. Okay. Clear?
Mm-hmm.
Yeah. So once we're done with the modeling, so what is the data modeling things? Okay, we have two modelings only, bottom up and top down only, right?
Yeah.
Yeah, okay, so that means that starting only we discussed Erwin modeling. Sorry, not Erwin modeling. Iman model and Kimball model. Kimball, yeah,
Yeah.
Kimball, Kimball. We're going with the Kimball model, all right?
Yeah.
Yeah. So Kimball model is a bottom up, Iman is a top down. Okay.
Mm-hmm.
So coming to the bottom up, again one more definition they're going. Often the results of a re-engineering effort. They usually start with the existing data structure from fields and applications, screens or reports. These models are usually physical, application specific and incomplete form of an enterprise perspective. This may not be promoted the data sharing, especially if they are built without reference to another parts of organization. See here, in a bottom-up model, what the thing they're doing, they already have some physical model. Okay,
Mm-hmm.
okay, they're just taking the already constructed thing as like their reference. Okay, from there they will inherit the features and they will try to build the one a new model. That means re-engineering effect they are trying to do. Okay, and require they are going to add a new features. Simply, I will tell you one example. I want to construct a one house. Okay,
Mm-hmm.
in my street, one person built a one a very beautiful house. Okay, and I'm also asking my builder or engineer try to build a house for me with the same model.
Mm-hmm.
Okay, otherwise I think in your same many villages you are seeing that okay people are following the same type of a houses only. That means suppose there are two friends, they will try to construct the house in the same model. They are passionate like that, correct?
Okay.
Okay, so first of all, I constructed my house and I will ask my builder, try to construct your house with the same model, right?
Mm-hmm.
Then just like with one reference, from there I am seeing that and simply I can able to, suppose if require, I will give us some new modeling things also, correct?
Yeah.
Okay, I'm clearly showing the some view to you, okay? So from there,
Mm-hmm.
step by step, I can construct. Coming to the top down, it is a logical view. Okay, in the same manner, I will take one more example. What is the thing here? I have seen one model of house in some another city. Okay,
Okay.
okay. I'm just have some image. Okay, in my mind, I have a complete picture, but I need to explain the complete picture to my builder. Is it possible to explain each and every clear-cut details to that person?
No.
No, it's a highly impossible. Right?
Yeah.
Your thinking is a different. That person is a different. Okay, that person is unable to read your mind. Okay, it's a highly difficult thing. So this is the reason. Okay, that person is explaining each and everything. Okay, so and I need to go with complete each and every level, right? Then only I can able to show your final picture to him, correct?
Yeah. Yes.
Otherwise simply based on his ideas I will build and final picture is like a one thing and his expression is one thing like a one thing, right?
Mm-hmm.
Like the same type of mistakes will happen in our business also, correct?
Yeah.
Yeah, they are expecting one thing. Your business people are expecting and one thing. You are customizing one thing, right?
Mm-hmm.
Like so many problems will happen, right?
Yeah.
See, yeah, simply I can able to tell like tell like one web application. Okay, I want to build a one website. Okay,
Mm-hmm.
if the person don't have any idea about creating a website, okay, you will build your website. Okay, just you will get the some information from them and you will build a one website. Once you've done all the implementation, simply you show that website to the person. Maybe that person not like that UI all the thing.
Mm-hmm.
Again, I need to rebuild my complete website. Correct. Yeah, to avoid this problem, what the thing people will do before building their website, they will go with the two or more templates, correct?
Yeah.
Photoshop templates, they will go with it. Yeah, I need to choose that from there. I will choose a one thing from the best template. I will go with it. Right?
Yeah.
Okay, here the complete. Okay, see here. On the another hand, these are top down or created in an abstract way by getting the information from a people who know the subject area. Okay.
Yeah.
That means I'm just getting the words from that person. A system may not implement all the entities in a logical model. Is it possible
Yes.
to implement each and everything what the thing he explained to you? No.
No.
Okay. Your business people is he know the each and everything. Okay. What he want, like in a pictorial format or in a designing format, he knows that. Simply I can able to build that. Right. Okay. Because to avoid this misunderstanding, so the business also maintain their well-known person all the business area. Correct.
Yes.
Means who can able to project all the information they will hire. Correct.
Yeah.
Like this. Okay. So we can able to relate our regular thing to our data warehousing things also. Clear? Okay. So like this we have a data modeling things are there, and coming to the differentiation between a OLAP and OLTP. So OLTP is the operational data and this is the consolidated information, right? Okay. So what is the purpose of your OLTP? To run your fundamental business task. That means regular business. Okay. And by using the OLAP, I can able to take some decision support. Otherwise, I can able to do some problem solving. Correct.
Yes.
That means in your particular business, okay, you have a 10 stores are there. In that 2 stores are not doing their business properly. That means it is not producing the much revenue. Simply you will put much concentration on that particular store only. What is the thing is happening there, correct?
Yeah.
Like that I will identify the problem and I will provide us some solution also. Okay. And so your OLAP reveals the ongoing business process. The day-to-day transaction it will show that. But your OLAP, it can able to speak about complete organizational thing. What is happening in your organization completely, right?
Yeah.
Okay. And here, insets and updates. Your OLTP is highly normalized because of reason insets and updates are very faster, correct?
Yeah.
Yeah. But here, periodic long running batches are refreshing your data. So daily refreshing of data will be happen in your OLAP. Okay. And those jobs are slower compared to the OLTP. What is the reason? I need to update your billions of records, correct? That means I need to
Yes.
perform insert else update operation on a billions of records. But I have very less number of less volume of data here. But here I have a billions of records are there. Because the reason it will hit a performance. So to avoid that performance issue, Informatica provides that partitioning push down optimization concepts are there to avoid the performance issues. Okay. And processing speed typically very fast, and but here depends upon amount of data. Processing speeds means loading, feeding is slow, right? Okay.
Yeah.
And this query speed can be improved by creating indexes. Okay, you can able to increase your performance by using the indexes. Okay. And here coming to here OLTP, these queries are relatively very small, and here I can able to see the very complex queries, and that too it is performing the aggregation operation, right? Okay. In your day-to-day information, all the data got archived. OLTP information. They will maintain only minimum amount of data. They want to maintain a complete information, right? All the business data, they will take a regular backups here, but they will not take a regular backups here. Okay. That means the complete information. Each and everything they will maintain. Years of information they will maintain in a single place only. But here they will maintain only a 1 month or a 2 months transactions only they will maintain. They will take a regular backups in a OLTP, but they will not maintain any backups in a OLTP. The same thing here they're taking. Backup they will take a religiously. Operational data is a critical to run a business. Data loss is likely to entail significant monetary loss of legal and liability. So the complete information. So if I lost anything, suppose my product table got collapsed, okay?
Yeah.
My business is
Then the
gone, right? I need to maintain, then I need to rebuild each and everything, okay? Clear? But here no need to take any backups, okay? Instead of regular backups, some environment may consider simply reloading the OLTP information as a data recovery. So I already have a copy in a OLTP, right? Like a backups, complete information I have in a OLTP, okay? In a OLAP also, why I need to maintain a backup, correct? If your data warehouse got collapsed, okay, simply you will reload the data from OLTP. Okay, let me tell you one real-time example. Okay, I am running the data business from a 10 days, sorry, 30 days. Okay, from a 1st to 30th. Okay, so in that you identified that from a 10th to 15th data is not loaded properly. Okay, what the thing you will do that only particular data only will reload into your database again, correct? That thing is enough.
Yeah.
You already have that information from OLTP, only that information you will pick. Okay, otherwise you will try to load the 30 days data again. That means simply truncate complete information from your OLTP, reload the all the 30 days information. Clear?
Yeah.
This type of things you can able to see in a real time also. Okay, we also do the same thing only. Suppose, okay, I told you that example. What is the thing? Uh,
We did the flush load, right?
yeah, flush and fill load. That means let me explain the example.
Full load.
At the time of that performance tuning, I explained you one thing, right?
Yes.
We created a new columns in a dimension level, which is removed from a transaction level, correct?
Yeah, and then we needed to do the full load
Yeah.
to
Okay. Without
all that.
having, yes, without having the copy, that means without maintaining anything, simply I connected to my OLTP and reload the each and every information and rebuild the table, correct?
Yeah.
That is also one realistic example what I can able to see how this business is happening. Okay.
Yes.
And coming to the differentiation between data marts and data warehouse. Okay. Data mart is usually is sponsored at the department level, and but it is a completely organization level data warehouse. It is right. That means I can able to speak about an individual thing like in our previous picture. Sure. Here, this is a data warehouse. Okay, here these are the data marts. Data warehouse can able to speak about each and everything, right? Your data mart can able to speak about only a particular thing only. Okay, no need to discuss about the other thing. It will maintain a detailed information about this particular thing. Clear? Okay. Department level and developed with a specific issue or a subject in mind. Data mart is a data warehouse with a focused object. It is also a data warehouse, but with a focused object. Okay. Data warehouse is a fully on an enterprise level.
Yeah.
Okay, and a data mart is used on a business division or a department level. Okay, so I can able to split my business by using your data marts. Okay, some organization think that what is the need to create a complete data warehouse. I don't want to maintain a complete each and every organization detail. So just for my analysis purpose, I want to depend upon the sales things only. So for that, only some information they will load, not an entire organization view. Okay, purely depend upon your requirement. Here it will maintain a complete enterprise level. Okay, I can call a data mart is a subset. Okay, and subset of a data warehouse. A data warehouse is an integration of variety of sources. Correct. And by providing the decision makers with only one subset of a data from a data warehouse. Here I can able to provide a complete integrated environment. Okay, and see here I can provide a complete privacy, performance and clarity objects can be attained. Okay, here there is no privacy is there. Privacy is there, but that is organizational people. That means top level management. They can able to view any information. Correct.
Yeah. It's
But
all
it,
integrated.
yes, but at department level people, they are not supposed to view another department information. Okay, let me take over a simple example. Okay, so I am working in a finance team in my
Okay.
organization. So I have a day-to-day financial reports, end of the statistics I have with me. Okay,
Okay.
if I reveal the information, what will the things will happen?
Oh yeah. You're not supposed to do that with the
Yeah, a
another.
simple thing. Okay, I have a financial department at the same time sales and some another departments also there. Okay, salesperson can able to get the all the financial level. Okay, or any another department people can able to review the, he can able to, he have the access to review all your dashboard of a financial. Okay,
Okay.
If he is an expert in the financial area, simply he can reveal your business secrets. So what is the level of your business, whether you are in a profit state or in a loss state? Okay, if your business going to increase in coming days, okay,
Mm-hmm.
simply he can purchase your all your company shares, right? Otherwise, he is asking your person, his relatives or friends to purchase your company shares, correct?
Yeah, yeah.
Otherwise, simply if you analyze this, that your market is going to down.
Yeah,
Okay,
you can
if
sell the
you release the
shares.
business secrets to another person,
Mm-hmm.
your business will also get collapsed. Correct. The same thing.
Yeah.
Okay, the same thing you can able to see. If you are going to display a one dashboard, to access the dashboard, you have a different level of users. Okay,
Mm-hmm.
that users have some restrictions. They can able to view only this part of a business only. Okay,
Okay.
they will split like a region wise, business level wise. They will split the your dashboard. That means they will create a different users of a dashboard, and they will give a permissions to only that particular dashboards only.
Okay. Okay.
They are not supposed to view the entire worldwide thing. Worldwide thing, who
Yeah.
can view complete top level management? They will review the
Yeah.
worldwide. Okay,
Mm-hmm.
if I am a India level business head, okay, I can go with the only the India level thing. That's enough for me. Correct.
Yeah.
I don't want to see the business secrets of our US, right?
Mm-hmm.
But people are also don't want to provide that. What is the need of that information to you? You are doing the business in India. Only take care about the India information only. No need to see the all the another information. Correct. And
Mm-hmm.
at the time of seeing the dashboard, clearly they are providing on a disclaimer message. If anything goes wrong, you are supposed to pay the all the consequences, right? See, clearly in my organization, if I try to open any dashboard, at the end they clearly show that you are viewing very confidential information. You are, if anything goes wrong, you only the responsible.
Oh.
Clearly they'll maintain that thing at the end. You are opening this thing, okay, and it is containing the confidential information about the business, and you are not supposed to reveal that. And who is opening this thing? They will monitor all the tracking also. Means who
Yeah.
is
Yeah.
opening the dashboard? They have a complete
Mm.
log information, right?
Yeah. Yeah.
Yeah.
They can track it. Who
Yes. Yes.
access to
Yes.
information.
Okay. And sometimes, okay, by making unnecessary locks, okay, if your dashboard got a struck from by you only, you done some unnecessary linking, and by that your dashboard is going to be crashed. Okay. Immediately you
Mm-hmm.
will get escalation from all your business. So this type of things also at the time of testing we got that thing. Okay.
Mm-hmm.
We need to do a dashboard testing also. Okay. This type of things you can able to see. So you are not supposed to reveal any information. Okay, that means because of the reason we'll maintain a fully security in a data mart wise. Okay, coming to the warehouse wise, it have a security and it is only can be able to view by a top level management. Okay,
Okay.
so we're done with all the data warehouse concepts. Only one concept is a pending staging thing is there. Okay,
Okay.
can I go with it? It will just take a 5 minutes.
Uh, can we do it tomorrow then?
Yeah, no issue, no
I
issue.
have
Yeah.
offshore call.
Okay, okay. We'll just do with the staging area. After that, we'll go with the Informatica. Okay.
Yeah, yeah, sure, sure.
This is
Please
just a
start.
simple thing. Okay. We already know about this concept. Uh, I think you
Will
don't
be
know.
just yeah, go over it tomorrow so that
Yes, yes, yes. We'll discuss this concept tomorrow.
sure.